we are going to discuss laws of conservation of different quantities like mass, energy, momentum, etc., that are used, that are so important in applications of this subject that we are studying, fluid mechanics. With this, an important equation which is very commonly used in its in the engineering and otherwise mathematical applications, known as Bernoulli's equation. Bernoulli is the famous mathematician who worked in so many fields of that are related to mathematics, physics, and so on. He developed this equation, and after his name, we call it Bernoulli equation. Bernoulli equation is really based on laws of conservation, and when we say that laws of conservation, we mean that the quantities like laws of conservation of mass, energy, momentum, etc. So we apply the laws of conservation of mass equation to balance the incoming and outflowing rates in a flow system. So obviously we have to equate, and we know that the mass cannot be, neither it can be created nor it can be destroyed. So a certain amount of mass that is flowing through a particular system that is under consideration, the mass that is coming in and going out has to be balanced, and it has to keep its balance. So we need to understand these things, and similarly we recognize various forms of mechanical energy and work with energy conservation efficiencies. Similarly, we will understand the use of and the limitation of Bernoulli's equation. When we derived the Bernoulli's equation, we derived it with certain basic assumptions. So those assumptions are physical, but since we developed this equation, therefore they are mathematical assumptions as well. So what are its limitations? So we need to discuss those limitations as well, so that we are careful when we apply this application, when we apply this equation. We need to understand and we need to know in our mind whether this equation can be applied to a certain phenomena or not. Similarly, we work with energy equation and so on.